Hello, everybody. Thanks for joining us for the Map All the Things with Mapbox GI with Evan Savage. My name is Paul. I'm a software developer at Dispatch. And if you have any questions throughout the session, feel free to add them into the chat, and we'll address them if we can during, or we can also have a Q&A at the end. So this advanced theme is sponsored by Roof, ROOF. A huge thank you to them for their support of Startup Slam. So, from FANG scale spam detection systems to STEAM education modules for teens to persistent augmented reality games, Evan Savage has built many things for many people over his decade-long career in the software industry. He's here today in his capacity as tech lead for the MOVE project, which is a collaboration between Code for Canada and City of Toronto Transportation Services to build the future of transportation data management at the city. And without further ado, Evan Savage.
Thanks so much, Paul. This is going to be a bit of an interactive workshop format. And so I'm just going to drop a link to the GitHub repo for this into the chat now. I'm going to do a bit of a preamble, a few slides. Most of it will be actually going through some of the live coding to set up a map and see some of the things that we can do. But just in case you want to go and set that up during the preamble, you're more than welcome to. All the instructions stuff that we'll be using are in that GitHub repo. So before we get started, I'm definitely curious to know from people who are listening, what's your, just drop into the chat whatever your level of experience with maps or mapping or geospatial data is. If there are things you've worked on before, if there are things you want to learn, just message in the chat, and definitely would love to hear some of the things that people are here for or looking to get out of it. But while you're all doing that, Paul already gave a wonderful introduction, so I won't spend too much time on this. But as he said, I'm working through Code for Canada with the City of Toronto on essentially transportation data systems to manage a large city's worth of collision, traffic volume, and other road network related data. And awesome, thanks, Adam. Yeah, and that's great. I think it's really great that people are coming to this because map data is so interesting, so important to a lot of the things that people do, and especially to governments. A lot of the things that they do as builders of infrastructure, as groups, as organizations that spend a large amount of their money, time, and effort putting things in physical places, governments are necessarily interested very deeply in geospatial data. You can kind of get a hint for that in looking even at the history of mapping. This is a map from the Civic Transportation Committee of Toronto back in 1915. So even over a century ago, they were already trying to get a map-based understanding of what exactly people are doing as they move around a city. Of course, Toronto was a lot smaller at that time. There was only about 500,000 people. But even then, there was still data sets that were worth putting on the map. The idea of needing to deal with map data, and especially deal with map data at scale, is not new. The only new thing really is what the size of that scale is. So 1915, 500,000 people. This might be about the most data you would have to put on a map at that time. In the MOVE project, we're dealing with collision data set spanning 35 years. That includes 1.5 million collisions. And that's not even the largest. We have also 120 million different traffic volume readings that have been taken over the same time span. And so there's a lot of things that you can do with smaller data sets that become much more cumbersome. As David mentioned, a lot of people have, if you use a map for showing a location, the kinds of techniques you use to put a single marker or a handful of markers on a map, and the kind you need to handle hundreds of thousands or millions of data points, very different. Obviously, can't cover them all in an hour, but hopefully this will give a bit of an introduction to how you can use Mapbox GL and some basic data visualization techniques to make sense of large geospatial data sets. All right, so that's kind of where this workshop comes in, better tools and techniques. We're going to switch over now to look at this repository. This is, you go to Saturday.net /mapple/things on GitHub. I'm just going to drop that in here again. Again, all of the instructions we're going to be using are listed here in the README. We may not get all the way through it. That's OK. It's there as a reference for people both during and after the workshop so that you can go over this material at your own pace, extend it as you want. It's really there for you to use and learn from. So essentially, we're going to be using a subset of that collision data set to produce a map, to work towards a map that looks something like this. There's a heat map of Toronto at the furthest zoomed out level that shows collision hotspots. And as you zoom in progressively, that gets larger, and eventually it switches to clustered points that show you a bit more of a precise view of how many collisions there are at different points on the roadway. Now, I want to underline, this is, again, the data set that's in this map is 150,000 collisions, nowhere near the full size of these data sets, but still some of the same techniques and tools are quite useful. So you'll notice a lot of things. Again, heat map, very good at showing sort of coarse-grained features, giving a way to quickly focus the user's visual attention. But the trade-off, of course, is that you don't know exactly where locations are. It's hard to tell precise counts of collisions at different points. So that's where switching that visual representation as we zoom in comes in. All right, so as we do that, so if you come into that Git repo and you clone it, we're actually going to switch over to a branch called start here. And the first thing you'll notice as you load that up after you install and npm run serve, first thing you'll note is that there is not a lot of stuff there. Of course, my computer is running several things at once. And so basically, right now, we don't have any of that. There's no map. There's not even the basic Toronto thing. There's just garish white text on a garish bright pink background. We're going to progressively build towards what you saw in that beginning, step by step, showing how we get there at every point of the way. Now, inside this repo, we have the usual package.json. The only thing that it's installing there is HTTP server, and that only so that we can serve this locally for use throughout the workshop. So when I run npm run serve, it's going to load up the server in this directory and show me what I'm working on. The site in and of itself is just a single page. We don't have separate CSS or JavaScript files. It's all within this one file. We have a bit of head preamble. We load Mapbox GL, GL's JavaScript and CSS from a CDN. We have all the styles sort of in line here in the HTML. We have a very brief bit of HTML here to make up the main body, which we'll be doing very little with except to get rid of this. Most of our attention will be focused on the JavaScript side of this. Just a quick view of that. We have a couple of global variables here to store the sort of basic map style of the map and the Mapbox GL map object itself. We'll get to that in a second. If I was working within something like React or Vue or another reactive component framework, I might bind these within the scope of a component or something like that. This is not a talk on reactive component frameworks, so instead we'll just do the easy thing and make them global variables. Get JSON, simple wrapper around the window fetch API, just issues an HTTP GET request to a URL, and then returns the response parsed as JSON. There's a function here, getStyle. We won't be touching this. Basically, what it does is Mapbox GL maps are built up out of styles. And usually underneath the data that you're showing, you want a base map or just sort of a basic set of country outlines, administrative boundaries, labels, that kind of thing. You'll want that on pretty much every map you make. A lot of the Mapbox GL documentation refers to like, oh, you have to set up an API key and you have to like refer to one of the Mapbox provided styles. You don't have to do that at all. You can actually just get styles. This, for instance, is a base map style from Esri, which is available openly. So we'll just use that. And we get the data that's necessary for that. So we're loading some metadata files for that in there. And then once we've done that, we get into Initmap. So we kind of want to be able to show a map container. We've already gotten rid of the H1 element, but we would like also to be able to get a reference to this map container. Similar to if anyone's ever worked with Leaflet, OpenLayers, or even a lot of UI libraries outside of mapping, it's pretty common that you have to attach your UI widget or something to a container element. This is no different. We're going to do exactly the same thing using getElement by ID, but we could use query selector or really any other way of getting at that DOM node. And then we're going to add that container into the options. And then finally, we need to make sure that we're actually creating a Mapbox GL instance. While doing that and passing the options to it, we can get ourselves a base map. While that is loading, yeah, and then as you see it, basically, this is what I mean by a base map. There's nothing really this actually is of minimal visual interest, and that's quite deliberate. The reason being that the purpose of our map here is to show data. For a navigational map, you might choose something with much more landmarks. You might choose something with clearer visual and color cues and that kind of thing. But in this case, we really just want a very muted canvas on which we can show data so that the attention is on that data and not on, like, is that a park or an administrative building? So we've got our first map. That's great. And that's a good start. The next thing we're going to want to do is we are working specifically with City of Toronto data in this doc and in this repository. And so what we want to do is we want to bound the map to only show the City of Toronto. So I've got a bounding box for the city there. And because we're bounding to the City of Toronto, we can also bound the zoom level. We don't ever need to see the map zoomed all the way out here anymore because we're only looking at a single city in it. So we can set some zoom bounds as well. Now, as you might expect, the next thing we need to do here is add in these options to our options object. Again, we're sort of telling it through the center and zoom where the map view should start, what should be visible initially. And we're telling it through these max bounds, min zoom, and max zoom, the sort of parameters, how far I can move this. I can't pan it outside city limits. I can't zoom in indefinitely. Eventually, it will stop me. So that sort of helps define the limits of interaction with the map. All right. So far, so good. This, however, is not particularly, obviously, we still have to work with our data and get on this map, but we do have a good start. Just before I move on, does anyone have any questions at this point? Everything makes sense? Again, you can always refer back to the README. All right, if there are no questions, I'm going to continue on here. So we've got a base map. The next thing we probably want to do is add some data to that base map. Again, we've got that getJSON function here for that purpose. And so what we're going to do is we're going to add in our collisions dataset. Now, inside this repository, so I go to the repository root, there's that source directory where I have my index.html file. And there's also a directory called data. So I've got 3 files in here, metadata.json and root.json, as mentioned previously. Those are the ones that are going to give us that base map. We've already used those. We're actually interested now in this other one, collisions.geojson. If you're not sure, if you've never heard of GeoJSON before, essentially it's just a JSON-based format for storing geospatial data. And so what that looks like is it's pretty straightforward. You have a JSON object. Most GeoJSON things that you'll see will have a type of feature collection, and then an array of features. In this case, we're working with a collisions data set where every single feature is the lat-long point location of that collision. The other thing you can do in GeoJSON is provide properties, which are sort of additional data properties of each and every feature. So you can use that, and we'll see this throughout the talk. You can use that to really style different data points and different features in different ways. So it's really quite excellent for that. It is somewhat more verbose as a format than some more binary and compact geospatial formats, but it is also quite easy to work with. And there are, as we'll see, there's a lot of good support right within Mapbox GL itself for working with GeoJSON. All right, so we've got that. The first thing we need to do, going to add another global variable here, showing off wonderful programming practice of just throwing at everything in the top level scope. But we're going to do that just so we can have a reference to that throughout the rest of this code. And then in here, we're already fetching 2 of these files, but we want to be fetching another one. And so we're going to pull in our collisions datasets. And we also want to make sure that we do that. Now, at this point, we shouldn't see any visual change. I haven't actually done anything with that data yet. What's important is that we can see that it loads. So if I go to my network tab in my developer tools, I can see that I am in fact fetching that. That's good. So that means that we can actually start to use it. Now, if I wanted to, I could check that collisions data set and see that there are about 175,000 points in there. But I want to also be able to do stuff with it. And so what I'm going to do is sort of the Mapbox GL equivalent of waiting for onloads or DOM ready events, and basically say when the map has loaded, I want to call this callback, populate map. Now, the load event, I'm using the .on method of the Mapbox GL map instance here. There are a whole lot of other events that it offers. And there are a lot of ways to do things earlier than the load event or continuously throughout the lifecycle of a map as a user interacts with it. We won't cover those, but just know that they're there, and you can go to the documentation to see all the different kinds of events that are available. Now, in populate map, we're going to start. There's 2 sorts of things in Mapbox GL that we use to render data. The first is a data source, and that's basically telling us where we get data from. In this case, I'm going to add a source. I'm going to give that source a source ID of collisions and tell it that it's a GeoJSON, a source of type GeoJSON, and pass it our collisions object. The rest is kind of magical because Mapbox GL will go off and actually index this on the fly into a series of vector tiles, which are then rendered into the browser. That's pretty huge because it means that unlike previously, say if you go back 5-10 years ago and you wanted to do the same thing, you'd have to pre-render your tiles. That might take a while in of itself. And then if you wanted to make changes to those, that's quite cumbersome. So it really offers a much better, obviously it can't deal with huge data sets, but this by itself allows you to quickly start prototyping things with even data sets that are 6 figures of points large. And then we also need a layer. Here again, I'm going to give the layer a layer ID, collisions points. I'm going to point it at the collision's source. It doesn't really matter what I call this so long as these things are the same. And I'm going to make it a type circle. That tells it to draw points. I'm going to provide it with some min, zoom, and max zoom bounds, same as what we're using for the map itself. And then I'm going to tell it a bit about how I want these circles to be drawn. You can see a few things here. There's circle color, radius, stroke color, stroke width. Cool. And these will probably be familiar fairly for people who have, anyone who's done work in CSS or who's worked with SVG. It's roughly like looking at background color versus border color or fill versus stroke. Of course, every platform wants to call them their own thing, but the general concept is pretty much the same. OK, so right there, without putting much code in, we've already got a quick map together. First off, getting to a map with 175,000 data points on it that can actually be navigated pretty smoothly is in and of itself a pretty big feat. That being said, this isn't a particularly useful map. It's at the furthest zoom out level, it's a total mess and jumble of points. I can't really make out much of anything from this. If I zoom in, there's even though I can kind of maybe see that there's more points here and fewer points here, it doesn't tell me a whole lot. Like, is this intersection more serious than this intersection? I have no idea. So it's good that we got it all, that we have our data on a map, but we can really do a whole lot more with this. All right, so what can we do that is useful here? One thing we could do, as we saw in the initial map, as you might guess, is start to work with this in different visual representations. One such representation is a heat map. And what that means is that we're going to replace this I'm drawing every point with kind of a sort of blurred out representation of where the hotspots are. First thing I'm going to do is sort of pull my colors up here, just so I can refer to them a few different places. I'm going to change this type here to heat map. I'm also going to change the ID. I don't actually have to change the ID of this. It's just this helps me refer to it and understand what's happening in the code. Readability is always, 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 always worth it. And then I can start to use, I can start to replace these circle-related properties with properties that are more related to the heat map. So I'm going to provide two properties here, the color and weight. And while we're here, let's just try that out. Now, there are other properties, as we'll see shortly, that are useful in building a heat map. What we can see also from Mapbox GL is that, again, it's indexing this on the fly. So when you see that it takes a few seconds to load up, that's kind of my computer chugging through it as it simultaneously tries to run hop-in and VS Code. Once it does load, we get a uniform sea of red. And that's not so great. This is actually worse than our previous map because it gives us absolutely no visual information. And so what is going on? To understand what just happened, we have to understand a bit about heat maps themselves. A heat map is kind of like if I were to take each and every single one of those points, blur them out, and then add all those blurred points up. This operation of sort of summing blurred points gives us a raster image, each pixel of which represents the density of points at that location. What I'm doing with the heat map layer, and especially with the heat map color attribute, is I'm telling Mapbox GL to take that density and map it onto a color. However, I've provided it with a constant color here, which basically means no matter what the density is, you're going to render that pixel with this one color. We need to change that. That's obviously not super useful because it gives us no information about what the density is. So what we're going to do is we're going to replace that with our first Mapbox GL style expression. Curious, has anyone here in the presentation worked with Scheme, Racket, Clojure, any Lisp style languages before? If you have, this might look familiar to you as what's known as an S expression. If that makes absolutely no sense and you've never heard that term before, no problem. Basically, what's happening here is instead of specifying this behavior with a JavaScript function, Mapbox GL, when it was designed, one of the design decisions behind the library is basically making it possible to send these layer and source styles over the network. And to do that, we need an easily serializable format, such as JSON. But using JSON obviously precludes packaging those functions in there. And so what we do instead is basically a domain-specific language that uses this array here. So we can see I've set heat map color to an array. And basically what this means is, basically how Mapbox GL interprets that is, I'm going to apply this interpolate operator to these arguments. Obviously, I can also not use an array and just have a constant value as an expression. But a lot of the power of Mapbox GL comes from these operators and this ability to sort of set dynamic styling. So I'm interpolating, I'm making a linear interpolation using the density of the heat map. And I'm going to map that density onto this color ramp, sort of a 3-step color ramp that starts with a transparent color, goes to sort of a light red, and ends up in the dark red we had before. To complete that, I'm going to add a couple more colors in there. And then we're going to see what that looks like. Now, one thing that's important in this is that the alpha channel of this color, the 0 density color, is 0. What that means is that at the edges of the heat map, it's going to fade to 0. It's going to fade to a transparent color, basically. If I don't do that, I could provide a solid color, but then it's still going to fill in everything that's not covered there with a solid color. I kind of want to be able to see the stuff behind the heat map when there isn't data to see. All right, so here we are. Better than before, not much so, because it's still kind of there's a lot of, there are enough points there that it's just kind of a formless blob. So we're going to keep working on this. At this point, we want to bring in a couple of additional features here. First thing I'm going to do is I'm going to take, remember how we had zoom level 0 and zoom level 3? This is sort of, you might be asking, okay, well, why 0 and 3? And that's a totally fair question. What happened to 1 and 2? The idea here is that these are functioning as zoom level breakpoints, very similar to what you would do with responsive design for the web, where you have the width of a browser window or a viewport determining how things are laid out. In the same way, as you saw with the preview map that I showed you at the beginning, we have a heat map. It fades into points, and we do this for a deliberate reason, because what works at a zoomed out level might not be the best representation at a zoomed in level. By setting different zoom level breakpoints, we can tailor the visual representation of the data at different zoom levels to what is most useful at that zoom level, essentially. And so we're going to introduce a breakpoint here. Zoom level 14, there's no particular, that was basically determined by trial and error, testing with people on this particular data set. It will vary what makes sense for different data sets. There's no hard and fast rule there. So what we're going to bring in are 2 new properties here, 2 new sort of styling properties, heat map intensity and heat map radius. The first one, intensity, defines a sort of global multiplier on that density of the heat map. So if I want to like mute my whole heat map, I can do that through this. If I want to make it all much brighter, I can do that through this. Radius, you can see here, this kind of suffers from a problem of the radius of each point being way, way, way too large. Because you can see here, like a single point might cover 20, 30 pixels here. So we're going to use this to change that and reduce that value. Now, the other thing you'll notice is that we have another interpolate. We have also interpolate expressions for these, but we're now using, instead of the heat map density, we're using zoom. And the reason we do that is for kind of a subtle visual effect. As we zoom out, points get closer together. As we zoom in, they get further apart. And so we're using this sort of zoom ramping here to compensate for that and make sure that people can still see hotspots at a variety of different zoom levels. Otherwise, you would zoom in and things would spread out and you wouldn't see a whole lot. Or you'd zoom out and you'd see everything, like before, with the sort of all blurred together. And this already looks a lot more, it's much easier to see individual points of interest, which is nice. All right, now on to the heat map weight. You might remember from before when we showed the GeoJSON that each data point has a KSI property. Now, this is an important feature of this particular data set. We're dealing with collision data. KSI stands here for killed and seriously injured. These are collisions that were especially serious, in which someone was hospitalized or even possibly killed. Toronto has signed on to the Vision Zero initiative. That means that under that initiative, every single KSI collision is to be treated as preventable through proper design of roadways. That means we can improve everything from signage, we can add lane markings, we can change the timings of different signals, add protected bike lanes, widen sidewalks, change how visible things are around street corners. There's a lot of different bells and whistles and knobs that are tweaked to make for a safer, more usable road experience for everyone. So what we're going to do, because we want visual attention drawn to those particular points, we're going to use the KSI property here to dramatically increase the weight of those points. So again, we're blurring all these individual points together, but now we're telling Mapbox GL, these points are much, 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 much more important than other points. I do want to stress the number 3 here is not, this is not here to suggest that KSI collisions are worth 100 non-KSI collisions. There is no number that would make that a meaningful comparison, not by any means. But it is simply there for us to say we want more visual prominence assigned to these so that attention can be drawn to them. This is a value that you would probably determine based on your use case, based upon what you want to do and what you want to show and highlight with the data. But again, this is not by any means placing some kind of numerical value on human life. So here, by doing this, we can now all of a sudden see hotspots, not just where there are lots of collisions, but also where there might be a few collisions, but especially serious ones. All right. And to do that, again, we use the KSI property, and we use this special get operator, which gets the value of a property of each feature. All right. So we've now gotten to the point where we have a heat map. Does anyone have it's kind of a fire hose of information at this point. Does anyone have questions so far? If so, please feel free to drop them in the chat, and I'll sort of interrupt what I'm talking about to make sure that those get answered. Right. Just a couple more seconds in case anyone has anything they're typing up. We will also leave some time at the end for more of a Q&A session. So fair enough. Awesome. If there are no questions then, going to move on. Now, we probably won't, in the remaining time, get all the way to the map that I showed at the beginning. That's okay. By the time you've seen this, you'll probably have enough of an idea of how this looks and what styling different layers looks like to make headway on the rest of the instructions here. It is all laid out step by step in here to show the whole process of making that. But with the time that we do have left, I did want to show one more thing, which is the idea of, as I mentioned, moving from one visual representation to another as the user zooms in and out. So what we can do there is change. So first off, what we want to do is we want to start, remember how we added that breakpoint, the zoom level 1 here. What we want to have happen is we want our heat map to show up until that breakpoint. And then we want to slowly fade in a set of points so that we get the heat map when zoomed out and points when we zoom in. So the first step here will be to change this. Right now, we're showing the heat map all the way down. But if we do that, you notice that if you zoom in, the heat map is not particularly useful once I zoom in too much. It's actually arguably less useful than individual points because I've lost some of that precise location information. So I'm going to start by changing that to break at zoom level 1. But remember how we said we wanted to fade one layer out and one layer in. Similar to what someone might do, what a DJ might do to crossfade between tracks. When you're doing that, there's always a period of time during which both tracks are playing. Same here. If you're fading from one layer to another, you want there to be a zoom level through which both layers are visible, one fading out, one fading in. So we're actually going to add 1 to that. And that last zoom level, from zoom level 1 to zoom level 1 plus 1, that's going to be the zoom level across which we crossfade. Now we take the heat map opacity paint property here. So we're going to add that in. And what that's going to do, again, this is we're using the zoom value here to ramp from an opacity of 1 to an opacity of 0 across that zoom level. So while we're there, we can just sort of take a look and see what that looks like. And again, you can see that a lot of these have again, all of these style expressions are basically, when you have an array, it's just the operator followed by the arguments. So we're using a whole lot of linear ramps here from one state to another. There are other interpolation functions that you can use. There are other ways to, you can do even like a stepwise function if you want to. Interpolate's not the only one. It just tends to lead to, if you want sort of like smooth transitions between states, it's nice for that. All right, so now we've got that. As we zoom in, as we get about here, we should start to see it fade out. So we've got the fade out part. Again, my frame rate is not maybe the best while I'm running all this stuff, but you can kind of see the effect there. So we've got one layer that's been zoomed, that's been faded out. We also need a layer to fade in. So we're actually going to bring back our points layer. So there's collision points again, using the same source, circle, but this time it has a min zoom of zoom level 1. And we're also using, we've got the color, the radius, the stroke color, the stroke width, all great and fine, but now we've added also circle opacity. This is the circle equivalent to heat map opacity. And we're doing exactly the same thing with one small difference, which is we start at zoom level 1 with an opacity of 0, and we fade in to an opacity of 1. So you can see from this, it's not, again, the fact that we can even go through maybe a dozen different iterations of a map in the span of half an hour to an hour. That in of itself, again, if you think back to what it would have taken to prototype maps like this on even medium-sized data sets like a while ago, that in of itself is kind of magical. That's how far some of the tools have come. And it's really quite exciting, actually, to have that power at our fingertips now. All right, so now as we zoom in, now Mapbox GL does take a bit of time, again, as stated, to load the stuff at first, but once it does, we can do that seamlessly. Now, if you did not want that load time to be a problem, especially if you're working with larger and larger data sets, we have 175,000. If you had 175 million, we can't wait for that to load. What you would instead do is you would then start to pre-generate some of your vector tiles, and there are definitely tools for that. I wish I had more time to cover that, but I'm definitely happy to point people at links. And here you get that sort of zooming in and out feature. Now, so that's kind of, I'm going to stop there with the sort of live coding workshop side of that. I'm going to also just reset back to the original with the full thing to show sort of the what remains between where we are and the whole thing. But essentially at this point, we've seen a whole bunch of things. We've seen that you can seamlessly load in a GeoJSON file right into Mapbox GL and kind of have it just work by magic, which is really, really, really cool. You can even, I believe, pass a URL in here, so you don't even have to go through all the mechanisms of fetching and all that I've done here. We've also managed to get we've managed to do the transition from a heat map to points, showing off the first part of that sort of transition that you saw in this initial map, again, which will take a second to load, to between that and the points at a higher zoom level. The one thing we did not get to at this point is the clustering. I won't go too far into detail on that. Again, the instructions are available here, and you can follow them step by step to get that part done. But effectively, what it boils down to is there are 3 layers in play here for the clusters. There's one for the circles of the clusters. There's one for the text labels of the clusters, showing the numbers of points. And there's one for unclustered points, anything that didn't make its way into a cluster. That in of itself is kind of magical in that you can just define a couple of additional cluster-related properties on or options on a clustered source and get the power of that functionality as well. So there's really, really a lot of stuff that you can do with Mapbox GL in terms of getting large amounts of data into a map, showing it, making it understandable, experimenting with different visual representations and blending them, and sort of helping your users understand these. And that is where I will leave off with that. So I'd like to leave the rest of this time. If there are questions, if there's anything people want me to touch on during this time, I'm all ears. Please feel free to drop it in the chat, or I don't know what other channels there are for asking questions, but ask them however you're able to. Oh, I think you're muted, Paul. Yeah. You're welcome, Donovan. Yeah, really quite a pleasure to show off some of the cool stuff that convince people that we do cool stuff in government too.
Let's try that now. Can you hear me?
Oh, there we go.
I wouldn't mind asking a question to kick off Q&A. I was curious if Mapbox GL has
Please
any
do, yeah.
time series component to it. I've worked with a library called Kepler in the past. Uber actually makes that open source library that does let you do time series mapping, so you can have an animation that comes out live.
Yeah, I'm not aware of any time series stuff built directly into the library, but it is possible to do things with like layer filters to sort of show only specific parts of a data set. So if you had a time series where you have like one attribute of it defines the time, you could just use that, change that filter to show different frames, basically. Yeah, so there's definitely flexibility there. It's just not, as far as I'm aware, built into it.
I'm also curious, I'll ask another question. Are you able to talk about how you've been able to apply this into the Move project?
Yeah, well, that's, oh man, I could talk for hours about that. But we're working with the collision and traffic volume data sets I mentioned. And so a lot of the same techniques, like a lot of the styling for this is essentially abridged from the stuff we've used for that in terms of visualizing the collision data set. We did build upon it to, let me see if I can pop up the slides, but we used a thing called Tippy Canoe, which is essentially a tool for making map tiles. Don't want to go there. Nope. And we use that to pre-generate map tiles. So when you see the heat map here and you see points zoomed in, because of the larger data set, we do that. We've also brought in alongside that additional features like we have sort of contextual stuff around where hospitals are, where schools are, where so everything that you're seeing with like the layers here, we're doing that with one data set in this example, but you can kind of build upon that to show more and more data sets and provide that additional contextual information. I'm trying to think of what else changed in there. Basically, we also added a lot of stuff around contextual pop-ups on individual points, around the ability to select a road. We also have the city, what's called the centerline layer, which is basically a vector layer of all the line geometry of different roads. And so we use that extensively to be like, okay, you want to click on this and see all of the traffic studies that have been conducted on this road, all of the collisions that have happened, and then filter that down. So this is really like kind of a packaged mini version of that in a sense.
Are there any other questions from the audience? Well, Evan, that was really cool. Thank you so much for presenting. And I love the format of and the preparation that you had going into it as well. So I was really appreciative. Thanks to all the attendees for joining as well. And a reminder that Talk to an Expert roundtables are happening all day, and you can sign up at the registration desk at Hopin. You can find that in the reception hall. Thanks again, Evan, and see you around.
Awesome. Thanks, Paul. Thanks, everyone, for having me here. I'll also stick around awkwardly now in case anyone does have questions.
Yeah, absolutely.
It's like the awkward goodbye. You say goodbye, and then everyone's like, for people who are sticking around, try to see if I can like pull up. There were in the slides. I gave a talk at another conference, and I also at that, because it wasn't a workshop style and I wasn't trying to show the code side of it as much, sort of went in more broad stuff about like, here's how we export GeoJSON right from Postgres, and like there's actually a lot of really, really, really great features in, like, essentially starting around like Postgres 9.5-ish or so, you start to get a lot of features around like JSON, and then later on stuff around vector tiling. Then more stuff around in the later slides, I had a bit of stuff on how to start using tools like Tippecanoe to generate those tiles in the background. And these are the kind of things that we stitch together with. We actually use Airflow to sort of manage a bunch of these data pipelines, including the ones that generate this. So definitely, if you were going to reach to do this same sort of stuff with even larger data sets, what I would usually do is like prototype on a smaller part of that data set and then build out towards, get the styling right, get a sense for what you want to do, and then start to look at pre-generation of tiles.
So you're using the mapping library as not as a prototype, but as almost like the investigative tool that empowers how you build the architecture.
Yeah, no, it's man, it's really great to be able to do that. I remember the days of working with like early versions of Leaflet, and
that's the one I use.
Yeah, it's still great for some use cases. They're not like a lot of there aren't that many use cases that are like I need to plop down huge amounts of data on a map. And so even up to a few thousand, I'd say, like if you're comfortable using Leaflet, if that works for you, if it works with your tool chain it's already used, like there's no good reason to switch away. This is more like we kind of looked at the different tools that were available at the time that we started the project and said, well, in terms of making it easier to handle this much data, that's where the advantage of Mapbox GL came in. So
you should check out Kepler as well. It's been like a mind-numbingly easy library for like quickly getting stuff onto the web to show. And that has the time series component to it.
Oh, that's cool. Yeah, that's the other thing. Like, this is for map-based data, but there's other tools that are better suited for other kinds. That's cool. I'll have to check out Kepler. I guess last thing I wanted to say about all this is the Mapbox GL also has, Mapbox also has a series of mobile SDKs. And they use, I believe, the same style specification, the same sort of styling language for that. And so a lot of the same stuff that you see here can sort of like pretty easily translate over to mobile experiences as well. Pretty cool stuff. All right, that. Awesome.
Is that native? It looks, yeah, native, right?
Yeah, I believe so. I haven't worked with it much myself, but it's kind of awesome to be able to even be able to sort of prototype maps for one platform and then kind of just more or less easily bring them over to another. Cool. Right. Well, anyways, thanks, Paul. This is lots of fun. Definitely have enjoyed both watching all the talks and coming here to give one. So
yeah, for sure. Thank you actually very much, Evan.